Now let's look into this problem. It states here that we will be using the generalized pigeonhole principle. First, let's really try to look at the possibility for this to be the, an example where pigeonhole principle can be used. So we have here the number of students in a class, to be sure that 3 of them are born on the same month. Does this fit the pigeonhole principle? And if it is yes, what would be our pigeons and what would be our pigeonholes? Now, let's talk about pigeonholes. Okay? Definitely, pigeonholes are the number of placements. And what are the number of possibilities? It's just like when we have here our pigeonhole, they are the number of options for those pigeons to pass through. In this case, our pigeonholes are actually your month in a year, because we are going to look at the minimum number of students in a class that their birthdays will fall, at least 3 of them will, the birthdays of at least 3 of them will fall on the same month. So month would be the holes. Month would be the placements. That would mean our pigeonhole represented by n is equal to 12, because there are 12 months in a year. Now, what would be our pigeons here? The pigeons would be the one, of course, in this illustration, they will be the one passing through, or they will be the one placed in the specific pigeonholes. In this case, what would be our pigeons here? They're actually your students, because they are the ones who will have birthdays on a specific month, and later on we'll be counting how many students are needed such that 3 of them will have the same month. Okay, just like here, we'll be counting the number of pigeons passing through the same hole, because hole would be our months here. Now, if we're going to look into this, just looking at not generalized, let's talk about this is not given. When I talk about pigeons and pigeonholes, we know that pigeons should actually n plus 1. Because if we're talking about just one, okay? If we're talking about just at least two of them, we just need at least 13, such that 2 of them will have the same birth month. Because in case the first 12 will really have they distributed well from January to December, it would be the 13th student who will meet the standard of having at least 2. So that would be for the original pigeonhole principle. But since we are now asked about that 3 of them, so we are not asking about 2, at least 1. So specifically, at least 1, just like 2, at least 3 of them. What would be the number of students? Of course, you can you can manually count this one, and you can just hope that at the 14th and 15th student, you could have 3 students sharing the same month. But the concept of generalized pigeon principle, since this will be our pigeon students, this is actually what we are trying to look at. Okay, this would be the number of pigeons. The number of pigeons we're going to look at is actually kn plus 1 according to our generalized pigeonhole principle. So it's actually kn plus 1, not n plus 1 in the previous pigeonhole principle. It's kn plus 1 because we have a generalized pigeonhole principle. And hopefully you're able to understand that we're using generalized than the previous pigeonhole principle itself. So the question now here is, how do we get our k? Because we have our n. To get the number of pigeons, we need the k. K is actually indicated by this statement. Okay? K would be, that is actually our k plus 1. If we're going to return to the generalized pigeonhole principle, its definition, you can look at the previous video talking about the number of, if n would be our pigeonholes, we have actually kn plus 1 number of pigeons, so that at least kn plus 1, at least 1 rather of the pigeonholes will have k plus 1 rather. Let me repeat it. At least 1 of the pigeonholes will be occupied by k plus 1, and that is actually equal to 3. Now what if the question here is 5? So that would mean this is also 5. What if the question is 10 of the students are share the same month, this is also 10. So actually, that is our K. The number of targets. So that is actually your 3. So to solve for K, that's 3 minus 1. K is actually 2. Okay? So by substitution here, K is 2, N is 12, plus 1. You'll have 24 plus 1. That's actually 25. You need a minimum of 25 students in your class so that 3 of them are born in the same month. Let's look into this analytically. Let's say the first 12 are well distributed from January to December. What if the second 12 are also well distributed from January to December? So that's 2 12s, that's 24 already. Again, that's correct. You need one more to make it 25, so that whichever would be the month of this, whether it's June, April, May, or October, that student will become the third student who will share the same month. So this answer of ours is correct. So what is critical in solving problems using generalized pigeonhole principle? First, identify the number of pigeonholes. Next, the target. Okay, usually the target is expressed as your pigeon's kn plus 1, and then the statement where that our target should meet, that's actually your k plus 1 to solve for your k. We will have another example for this to illustrate this better. Thank you very much for watching.